Okay, good evening everyone. Welcome to the Leitner Observatory and Planetarium. It's Tuesday night, our public night. And I'm out here on the observing deck at the Leitner Observatory and Planetarium. I've got two telescopes out here with me, our 12-inch reflector on this robotic computer-controlled mount. And I have a video camera connected to the back of the telescope so we could do some live views of the sky in just a minute. I have a little bit out of the frame of the camera right now, but I have a 5-inch reflector which I brought out tonight, which is one of my own telescopes, which I thought I would demonstrate a little bit tonight. It's partly clear, mostly clear. I'd say about 50% clear. It's a very pleasant temperature out here, a little bit windy, which is making the telescope shake a little bit. You'll notice that, but it's actually very pleasant tonight. Yeah, it's supposed to get more cloudy tonight, so I'm going to try to sneak in some observing here before it gets cloudy and talk a little bit about what's up in the sky this week and take your questions if you have any questions. So I'm Dr. Michael Faison. I'm the director of the observatory here. I usually run the Tuesday night public night sessions. We do planetarium shows normally when we're open to the public, and then we set up telescopes outside at our observatory for live viewing of interesting things up in the sky, which since April has been online. It's been this live stream where if it's clear, I'll point the telescopes at something interesting and talk about it. And if it's cloudy, I'll do something else. But trying to keep this live stream going for people who want to keep up with the Leitner Observatory and learn a little bit about astronomy. I really am here live. I really am here doing this live. I'm watching the chat comments off and on. So if anyone has any questions, feel free to post them in the YouTube live chat, and I'll try to pause every so often to answer questions. Yes, hello, Fred. Let me just talk about what I've got going on here. I've got the 12-inch telescope pointed at Jupiter right now. And before I show you the live view, because there is something interesting going on, let me just pan the camera around so you can see what the sky looks like out here. So there you see my shadow on the dome of the 16-inch, and there you can see the 12-inch. And the front of the 12-inch is kind of right there, and then the CMOS video camera is kind of right there. It's a little bit hard to see right now because the telescope is on the far side of the mount, and so actually there's this counterweight that's closer to the camera that the camera was trying to focus on a minute ago. And there you see the Farnham Gardens, which are lovely, and we can pan over here to the south and the southeast, and there you can see Jupiter and Saturn and a few clouds a little bit lower. And we can see the light pollution from New Haven, especially from East Haven and the I-95 bridge. You see an airplane flying towards us over there. He keeps scanning around. I can't really see any bright stars over in that direction. If I pan up, you can actually see some of the stars in the summer triangle. So there is Altair, that bright star you see right in the middle of the camera field of view. And then I don't think I can go quite all the way up to the zenith. Oh, almost. There's the star Vega, right? So I have to tilt my tripod back a little bit to get that star in the frame. There's the star Vega. So the three stars in the summer triangle are bright stars that you can see all summer long in the northern hemisphere. You basically see them overhead at sunset in the late summer to late fall, up for a good part of the season from around end of June until sort of end of November. You can catch them at sunset. Of course, as the Earth orbits around the sun, they're going to shift further and further west at sunset as time passes. So Jupiter and Saturn are right over there. The dwarf planet Pluto happens to be right between them. Of course, can't see that with the naked eye. Could definitely see it with this telescope. In fact, we've looked at Pluto with this telescope before. And no moon tonight. So last week we had a nearly full moon. Tonight the moon is last quarter. So that means it's orbited around the Earth another 90 degrees from where it was last week. And so you'd have to get up around midnight or so to see the moon when it's at this phase. I saw it last night when I was heading home. So it just happened I was riding my bike down a street in the direction of the moon rise, so I saw a really pretty orange last quarter moon rising last night on my way home after my observing class. All right, let me swing back around to the telescope, and I'm going to show you what Jupiter looks like right now, because something interesting is happening. The temperature is really nice, just feels really nice tonight. You know, it feels nice like this in the evening, roughly 2 to 3 weeks out of the year. And the bugs aren't too bad. The crickets are going to town. The crickets are really loud. You can probably hear them on my mic. You know, they can tell it's getting cool. Isn't there some way that you can measure the frequency of the chirps from the crickets and use that, convert it to get temperature? That might be an urban legend, but I think there's something scientific to it. Yeah, the crickets are getting desperate to find each other because it's getting cooler. Okay, I'm going to switch my streaming control over to the telescope control, and you're going to see here a live view from the telescope, right? So I can show you again what the telescope is looking at on the chart. Right, so you can see that yellow bullseye is showing me where it thinks the telescope is pointed in the sky. And then if I turn on the software that controls the video camera that's on the back of the telescope, which I got in focus a little bit earlier, this is a live view right now of the planet Jupiter. And it's interesting. I can definitely see some surface features, even though it's a little bit windy and there's a little bit of turbulence, making it a little bit harder to see what's going on. I can definitely see some details in there. I can see the great red spot, and you know, it looks to me like there might be like a little speck of dust in there, right? Can you see that little speck of dust? I'm just zooming in a little bit. Now, zooming in doesn't necessarily improve the view. For one thing, I zoom in enough, I start to see the individual pixels in the camera. But also, there's just a limit to how sharp the image can be given the telescope I'm using and given the atmosphere that I'm looking through and the turbulence in the atmosphere. I can make it a little bit sharper by taking a slightly shorter exposure time. So I can maybe improve it a little bit that way. There you see the great red spot, and you see the south equatorial band, the north equatorial band, and some of the zones, the lighter colored zones on the planet. And you know, is that like a piece of dust on the lens or something? Hey, there's a moon right there. And actually, if we zoom out even more, when I say zoom out, this is a digital zoom. I'm not actually changing the lens in the camera or changing the focal length of the telescope. I'm just blowing up the pixels more or less. If I increase the exposure time, you can actually see all of the Galilean moons here, or at least 3 of them. There's one right there. I hope you can see that. There's one right there, really close in. We saw that before. And there's another one way over here, quite a bit further away from the globe or the disk of Jupiter as we see it through the telescope. So I'm being a little bit disingenuous, a little bit sneaky here. I know that little dark spot there is the shadow of one of the moons, because I was looking at this earlier. So you can actually get little mini Jupiter eclipses when the disk of, or the sphere of the moon can block sunlight from the surface of Jupiter. And if you were on Jupiter, you'd see a little, well, you can't stand on Jupiter, obviously, but if you were floating in the clouds of Jupiter, on tops of the clouds of Jupiter, you would see the moon come in and cover the sun and get a solar eclipse. Of course, the sun looks smaller from Jupiter because it's much further away, but you would get a little eclipse. Now, I assumed when I first saw this image is that, oh, that moon over there is casting a shadow on Jupiter. And I wanted to know which moon it was. So I went and looked in Stellarium, right, which is my standard desktop planetarium simulation program. So let me switch over to Stellarium here and show you the configuration of the moons right now. So, you can see the configuration of the sky right now, and I'll talk about that a little bit more in a minute. But I want to see which moons are which. So I'm going to zoom in on Jupiter here. I've demoed this software many times before in this live stream. It's free software that you can download from stellarium.org, and has a lot of nice features, especially if you're getting into astronomy or trying to learn the sky. If you're looking at Jupiter through your telescope and you want to know, hey, which moons are which in a line there. Okay, so that moon that was way off to the left is Callisto. The moon that's off to the right is Europa. And then this moon that's right next to the Jupiter is the moon Io. Right. So Io is casting the shadow on the moon Jupiter. And Ganymede, I actually saw Ganymede a little bit earlier in the evening, and I thought Ganymede was casting a shadow. There's Ganymede. This is actually the way it looked to me a little bit earlier in the evening. Ganymede went behind Jupiter while I was getting ready to do the stream. And then now here's what it looks like right now. There's Io that's come out around from the front of Jupiter and is now still casting a shadow on Jupiter. Now this is obviously a computer simulation. We can't see this much detail using our telescope, but we can see that, yeah, that's basically what's going on. The telescope, the image is tilted a little bit relative to this because I have a little bit of a tilt on the camera. But I still think that's pretty cool that I can see Io and the great red spot and then the shadow of Io on the front of Jupiter. You would definitely be able to see that with your eye if you were looking through an eyepiece on a telescope like this, or one of the 8-inch telescopes that we normally set up for public night, for Tuesday public night. I think the image actually looks a little bit better if we zoom out just a little bit, so you know that we're not quite seeing the pixelation as much, and it looks just a tiny bit sharper. Now, as I've said before, there's a trick you can do to get a sharper image, which is to take a little video. I'm gonna do that right now. So I'm actually saving a little video of Jupiter, and later on I'm going to use some software to combine the sharpest frames from the video to make a sharp, better, less noisy image of Jupiter. And I will actually post that. I'll do this tomorrow. I'll post it in the comments, or not the comments, but the description for this video when it goes up tomorrow of the recording of the session. So then you can see potentially just how sharp, this image could get looking at Jupiter with a 12-inch telescope, essentially at sea level, in the middle of a city with lots of light pollution everywhere and lots of lights. Yeah, besides the fact that it's a little bit cloudy tonight, it's a little bit humid, not as bad as it has been this summer, but it's a little bit humid and it's a little bit hazy. So the only stars I can really definitively see right now are the summer triangle, so Altair, Vega, and Deneb. See a few stars in Cygnus the Swan, and then I think it's cloudy over there in the east, which is preventing me from seeing anything interesting over there, and I think it's cloudy to the north as well. Okay, my images are saved, my little video is saved. So I thought I would show you Saturn also really quickly, just in case it gets prohibitively cloudy before we come back to it. So I'll show you Saturn, and then I want to talk a little bit about astronomy news and a little bit about what's up in the sky. And then I wanted to actually look at some interesting objects that are in the Milky Way. The Milky Way is going across the sky, actually kind of close to where Jupiter is, and then up through the summer triangle. And there's some interesting nebulae and star clusters in the plane of the Milky Way that I wanted to talk about. And if it stays clear, we'll look at them with the 12-inch telescope. I also, if I have time, I'll demo my 5-inch telescope, which is over here. Like I said before, if anyone has questions or requests, if you'd like to see a particular object, post them in the chat, and we'll see what we can do. Okay, let me move over to the telescope control, and I won't bother. Well, no, I will show you the telescope control here so that you can see what's going on. Let's see, I will switch back to, oh, I didn't show you, you didn't see me taking the video before because I hadn't switched the camera control. Let me switch it back so you can see what I just did. So while I was talking, you were looking at the simulator view of Jupiter, but then here's the actual telescope view of Jupiter. And so I took a video, about a 2-minute video of Jupiter a minute ago, so we'll see how it turns out. Okay, let me move to Saturn right now. All right, so all I have to do, is this real astronomy? I'm just going to click on Saturn right there and select it from the list, and then I'm going to click on slew, and the robotic motorized mounts will move a little bit to the left to align with Saturn. This kind of automated motorized robotic telescope is what, of course, what all professionals use for pointing telescopes, because if you're trying to get a good image of a galaxy or a planet or whatever, you don't want to spend a lot of time looking for it, so you use a professional mount. When I'm teaching observational astronomy, I will usually do I'll have the students use push telescopes, where you just push the telescope to different positions to learn how to find things in the sky, and then later on when we're doing more advanced projects, we'll use the robotic mount to actually just find things. Okay, let's look at the image here. All right, let me bring up the video controls. All right, there's Saturn. Saturn always looks great. Well, I've seen some bad images of Saturn. So let's zoom in a little bit here. See the rings really clearly, and I'm going to increase the exposure time a little bit. Hey, it is sharper. We were looking at this last night in my observing class, and the seeing was really bad. The turbulence was really bad. I can definitely see some detail in the rings. I can see there's a gap, the Cassini division, between the inner ring and the outer ring. That's a gap where there are no particles in the ring, caused by the gravitational pull of one of the satellites. The satellite Enceladus will actually pull particles that are orbiting at that distance. So that's why you see a gap in the rings. That's actually why you see most of the gaps in the rings, is there's some kind of gravitational interaction with one of the many, many small moons that are orbiting around Saturn really close in. Hey, that doesn't look bad. I adjusted the focus a little bit earlier, so I think the focus is probably as good as it can get. I can see, like I said, the gap in the rings. I can see the A ring and the B ring. I can see there's kind of a white equatorial band on Saturn right now near its equator. Saturn's weather isn't nearly as dramatic as Jupiter. It's not as massive, it's not as dense, it's further away from the sun, just doesn't have as much going on. But sometimes you do see storms in the atmosphere of Saturn, and there's been this white equatorial, zone around the equator of Saturn for a few years now. I can also see the shadow of the planet on the rings. I'm going to go ahead and save a video of this as well. So I'm going to capture some video and we'll see if I can make it sharper. Actually, before I do that, I'm going to decrease the exposure time a little bit. That can help get a sharper image. It makes it look dimmer, but then if you actually combine 100 images, it doesn't look quite as dim as it does in the individual images. Okay, let me try to save that again. I can see the shadow of the planet on the rings. And then something else that's interesting is that you can really clearly see that the rings are tilted towards us, right? We're seeing the top of the rings, not the bottom of the rings. And so this is telling us that it's summer in the northern hemisphere of Saturn. So Saturn has a tilt to its rotation, just like the Earth does. And as Saturn goes around the sun, sometimes we see the northern hemisphere of Saturn tilted towards us, sometimes we see the southern hemisphere of Saturn tilted towards us, and sometimes it's spring or fall on Saturn, and we see it basically edge on. And for people who like to see the rings through a medium or a small telescope, that's always a sad year or two when you really can't see any detail in the rings because they're basically edge on. For astronomers who like to study the small moons of Saturn, that's the best time to look for the moons and study them, because then you don't have the bright rings blocking your view of those small moons that are close in. Let's see, someone's asking, what is creating the jump in the image? Is it the wind or the atmosphere? Right now it's mostly the atmosphere. So if you were to see the whole image kind of shift back and forth like that, that would be mostly wind shake. But when you see the image kind of shimmering and kind of wiggling and warping, that's mostly caused by turbulence in the atmosphere. So there are big cells of hot air rising up in front of the line of sight of the telescope, and that makes everything shimmer, just like an oasis, or just like the road, looking over a road on a hot day. Okay, I got my images, I think. One last thing that I'll do is zoom out a little bit so we can see if we can see any of the moons of Saturn. So you can see any of the moons of Saturn. So there's one bright moon of Saturn, which is the moon Titan. And let's see. Okay. And maybe I'll increase the gain a little bit also. Hey, okay, so I'm starting to see some moons. So there's Titan right there, I presume, unless it's further away. No. So there's Titan, and I can see a couple of other small faint moons. You know, let's look at Stellarium and see what they are. Hey, whoa, I see a lot of moons now. Oh yeah, there's lots of moons. Okay, by pumping up the gain, I make the image very noisy. Basically, changing the gain on this camera is similar to changing the ISO on your digital camera. So it means you can see fainter things in an image, but also it looks a lot noisier. Space is creepy and beautiful at the same time. That's true. What's creepy about Saturn? I think Saturn is just beautiful, although, you know, it's a giant ball of gas out there in the outer solar system. By the way, it takes about 30 years for Saturn to orbit the Sun. So it takes 30 years for it to go through all of those seasons and all of those ring plane orientations. So in 30 years, we'll see Saturn look like this again. So then it's every kind of 15 years that you go through the ring plane. So, you know, that was about 7 years ago, and about 7 years from now, we'll see the rings edge on. Okay, look at all these rings. Look at all these moons. So let's see which ones are which. So I'm going to go back to Stellarium, and I'm going to leave the view of Jupiter, and we'll zoom in on Saturn. Okay, now there's a little bit of a tilt. I actually can maybe fix that a little bit by doing that. It doesn't make a big difference. There's a little bit of a tilt that I can move out of the way. So we've got the moons, a little bit hard to read because there's so many words on the screen. There's Titan, Rhea, and I guess that's just a background star. Yeah, so that just happens to be a star that's behind Saturn. So I thought it was a moon, but the moons are Titan, Rhea, and then up here we have Iapetus, one of the smaller moons. And then here we can see Tethys and Enceladus, and then Dione over here, and then these are background stars. And then Mimas, I'm sure we can't see Mimas. That's the smallest moon, and it's on the far side of Saturn behind the rings. So let me go back to the live image, and let's see if we can identify them. So again, there's so many, it's hard to keep track. So we have, and let me point these out to you. So we have Titan and Rhea, Tethys, Enceladus. I've already forgotten what that one is. Let me go back to the image. Oh, Dione. Dione's right there. And then there's, I think that this thing way over here is just a background star because it's not showing up as a, moon in the simulator. Well, that's really neat, and I'm going to take an image of that just to have. And that little speck of light right there is the moon Enceladus, which is a really interesting moon of Saturn. It's small, it's very small, smaller than the Earth moon. It's made of ice, and it's orbiting very close to the rings, and it does get tidally heated by the gravity of Saturn. And it actually spews out water ice. So there is liquid water underneath its surface. And every so often there's a patch of warm water, especially near the south pole of the moon. Water ice comes out. And there's some interesting evidence from the Cassini mission that there could be organic chemicals and salts, and in particular hydrogen ions, in the particles that came out of Enceladus. And so that's not evidence that there's life as we know it on Enceladus, but it could be evidence that the building blocks of life. What you need to have life as we know it could be there. So a lot of people who are interested in astrobiology are very interested in Enceladus and perhaps sending a mission to Enceladus, maybe not to land on the surface, but to study the ice plumes that are coming out of the vents on Enceladus. That could be really exciting. Okay, well, let me talk a little bit more generally about what's up in the sky, and I'll do it fairly quickly so that we can then point at some other interesting objects. It's still kind of cloudy in the northeast, but not too bad in the south and overhead. Yeah, so I think we'll get some Milky Way objects. So let me just talk about what's up in the sky this week. So if you do get a clear night, or if you go out tonight and look for some of these things, you can orient yourself. So I'm going to switch over to my sky map here. So this is the evening sky map for September, and the sky map, the sky calendar people put out a new map every month, updating what stars are out at your latitude and what planets, where's the position of the planets. That's actually one of the really useful things about the evening star map or the monthly star map, is you can find out where the planets are. So here's Jupiter and Saturn to the south for me. Mars would be coming up in the east. I did see Mars last night at around midnight. So it's not going to be too much longer before we'll see Mars kind of over in the east-southeast horizon as seen from the observing deck here. So we could start taking a look at Mars. We're going to have a Mars opposition a little bit later this year. That should be a pretty good one. And Mars is going to be closer than it is on average. And so Mars is going to look really good this fall. You can see the blue light is the Milky Way. So like I said, we're going to look at maybe we'll look at M11, and maybe we'll look at M27, and maybe we'll look at M57. Yeah, some of these interesting bright star galaxies, or not galaxies, no galaxies in the plane of the Milky Way. You have to look away from the Milky Way to find galaxies. But some of these brighter star clusters and nebulae. Maybe we'll look at M15, which is a globular star cluster. In terms of star patterns, the bright stars that are out, well, if you actually, Jupiter is going to be the brightest thing in the sky if the moon's not out. If you actually look kind of down to the right of Jupiter, you can see the bright stars in Sagittarius. So Sagittarius, the teapot, it's kind of down and to the right of Jupiter. It's a little bit too hazy for me to see it with the naked eye. I could probably, if I were to take a picture with this camera, I could probably see it. And then those three bright stars overhead are Vega, Deneb, and Altair. Looking further to the north, it's a good season for looking at Cassiopeia, which is the W constellation, 5 stars in a zigzag like so. And of course Polaris, it's good to know where Polaris is. Polaris is always in the same place no matter what time of night, no matter what season, because as the Earth rotates and orbits around the sun, it's always keeping its axis of rotation pointed at the North Star Polaris. If you have a favorite observing location, like I'm always observing here from the observing deck, once you know where Polaris is going to be in the sky, I can't quite see Polaris now, I think it's a little too cloudy over there. Once you know where Polaris is going to be in the sky, it's always going to be there from that location. Really, the only way you can change your view of Polaris is to walk around the Earth. Walk further north, where Polaris will get higher in the sky, or walk further south, where Polaris will get lower in the sky, until you get to the equator. And then when you cross the equator, the Earth is in the way, and you'll no longer be able to see Polaris. Let me show you some of these same constellations in the simulator, and I'll talk also a little bit about Pegasus. So I'm going to switch over to, actually no, before I do that, I wanted to talk about some astronomy news I heard today. I just have one thing that I thought was interesting that I wanted to talk about, which is this milestone in the construction of the Vera Rubin Observatory in Chile. So this is a project that's been going on for, I've heard about this telescope for 10, 15 years. So the project has been slow, but it's a big project. This is a telescope that's being built in the mountains in Chile. It's an 8-meter telescope, but the important thing is that it has a very, very short focal length. So for those of you who know anything about photography, if you want to have a wide field of view, you pick up a camera lens with a short focal length. Same is true actually with telescope eyepieces. If you want a wide field of view, you pick up a long focal length eyepiece, and you want a short focal length objective, if you can. Let's see, the focal length of this telescope is about 120 inches. What would that be in millimeters? 3,000 something millimeters? You know, the lens that I have on this camera is a 16 millimeter focal length lens, so it has a relatively wide field of view. So the focal length of this telescope is very short. It's a very fast telescope, so it has a very wide field of view. Now, you want to pair that with a camera that has a really, really big sensor so that you can see a lot of the sky at once. And there was an interesting test of the camera, which is being built in California right now. And they took a picture of a head of broccoli. So first image from the camera that's going to go on the Vera Rubin telescope. By the way, one thing about the telescope, it used to be known as the LSST, the Large Synaptic Survey Telescope, I think is what it was called. And the idea is that it's just going to take images of the sky every night. And about every 3 or 4 days, it'll see the entire sky. So this is a really great tool for looking at things that change. So stars that change their brightness, like variable stars, transits of exoplanets. When a planet moves in front of its star, it dims a little bit and then comes back. Looking for asteroids that are moving around the sky. You can't scan the entire sky every night for asteroids, but this telescope can scan every 3 or 4 nights looking for asteroids. Flares, supernovae, regular novae. So this telescope is really going to transform a certain type of astronomy where you're looking for things that are changing night after night. There still will be a role for big telescopes to go zoom in and study objects at great detail, but this is going to be an amazing telescope. So anyway, I just heard this story on NPR today that they had done this test of the camera. Now the camera is huge. I think they said here that the width of the camera is 5 feet in diameter. So I have my little video camera on the 12-inch telescope. It's, I don't know, 2 inches or so in diameter. And the actual sensor that's inside there is a little square CMOS detector, like on like on this camera that I'm using, or like in your cell phone sensor, the camera in your cell phone. And it's an inch, actually it's not even an inch, it's half an inch across. So it's a square detector that's half an inch across. So this thing is huge, and it's actually many, many sensors connected together, and that's why there are gaps between different parts of the image. So if you actually dig into this a little bit, there's some interesting articles about how they actually set up the camera to make the image and how they chose this object to take an image of. There you can actually see the detectors in the camera. So this is really cool and a big milestone in this telescope, the Vera Rubin telescope, which is named after the astronomer Vera Rubin, who's the astronomer who discovered dark matter in the 60s. Yeah, why did they decide to take a picture of a piece of broccoli? The answer that they gave was, well, they thought it'd be fun, and it does show interesting structure, right? So this type of broccoli is kind of a fractal. It's the Romanesque broccoli that has the kind of fractal spirals in it. So that means that you can see detail on big scales in the image, but then if you zoom in and look at the individual pixels, you can see you can still see detail because it's like a fractal. You still see the structure when you zoom in. There was something I thought was a little bit misleading in, was it this article or was it the other one? There was some article here about oh yeah, here it is. The resolution is so good that a golf ball would be visible from 15 miles away. Now, what determines the resolution of the camera is not the size of the pixels. It's the weather, it's the telescope. I wasn't getting a super sharp image from this telescope when I was looking at Jupiter and Saturn just because the atmosphere is turbulent. Now, the atmosphere is fairly steady high up in the mountains in Chile. That's why we build telescopes there. But you can't just say definitively that the camera has resolution good enough. You're not going to be able to see golf balls 15 miles away with this telescope and with this camera. They're just sort of telling you basically how sharp the camera can be. But I thought that was pretty great. Okay, now I'm going to switch back to the simulator and talk a little bit about what's up in the sky. And we can then look at some of these objects. Let's see, do we have enough time? Yeah, we've got enough time to look at some other objects. Okay, so Jupiter and Saturn are certainly the stars of the show tonight. But like I said, we also have the Milky Way going across the sky from south-southwest through almost directly overhead, through the Summer Triangle. So there's Altair, Deneb, and Vega in the Summer Triangle, and then going all the way through to Cassiopeia. I mentioned Cassiopeia. There's the zigzag of Cassiopeia, and then down to the horizon. And I can start to see the constellation of Perseus coming up over there. Let's see if the simulator thinks that Mars should be up. No, Mars is not quite up yet here in New Haven. If we go a little bit later in the evening, I can run time forward here in the simulator. There comes Mars. Yeah, so Mars is rising at about, 9:30, 10 o'clock. And you need it to be a little bit higher in the sky to really see it. So 10:30, 11 o'clock is when you'd want to go out to look for Mars. And it is getting quite bright. So let me point out some of the constellations that are out. I'm going to label the constellations and draw their stick figures here. And I talked about this in the last live stream, but you can see here is the plane of the Earth's orbit around the sun projected up into space, what astronomers call the ecliptic. Now, we always see the moon and the naked eye planets close to the ecliptic. And there are special constellations that the ecliptic passes in front of that are the zodiac constellations that we use to keep track of the positions of the planets. So we have Jupiter here kind of in Sagittarius, which I still can't really see clearly. And then we have Saturn over here kind of between Capricorn and Sagittarius. And about every 30 degrees around the ecliptic, about every 12th of a circle, there's a new constellation. So Capricorn, Aquarius, Pisces, and so forth. So we would say that Mars is in Pisces tonight. And so those constellations are very useful for keeping track of the positions of the planets and the moon and the sun as we all orbit around the sun at the center of the solar system. Now, let me talk a little bit about some interesting constellations and constellation lore. Now, what are these constellations supposed to be? Well, let me focus here on the Summer Triangle and the constellations around the Summer Triangle. So it's easy to find these three bright stars, and if you're someplace where the sky is really dark, you can see the stars in Aquila, you can see the stars in Cygnus, sometimes called the Northern Cross, and you can definitely see this kind of rhomboid shape, this kind of squashed rectangle shape near Vega, which is part of the constellation of Lyra. So if I turn on the illustrations, you can see, well, what is the story about the constellation? What is it supposed to be? So Aquila the eagle right here, Cygnus the swan right here. Maybe we'll take a look at Alberio, which is one of my favorite double stars. That's another object we often look at public night, and we haven't looked at. I haven't looked at it all summer, actually. And then Lyra over here is the harp, right? Or the lyre, right? You know what a lyre is. And so it's interesting, you've got this kind of collection of animals and then a few sort of random objects thrown in, a shield, a harp. Some of these constellations are ancient Greek constellations, such as there's Hercules, the hero right there. So you see Hercules fighting with Hydra. Ophiuchus, the snake handler. So there's a myth about Ophiuchus. And then Aquarius, of course, Pegasus, the flying horse, Andromeda, and then Perseus, the hero, is coming up over there in the northeast. There's a connection between Perseus, Andromeda, and Pegasus. But I think there's some interesting sort of small, pretty constellations over here around the Summer Triangle that aren't difficult to find. And zoom in a little bit to show them. So you have here Sagitta the arrow. There's kind of a story that's the arrow, it doesn't really show up in the illustration because it's so small, it's kind of a little straight line of medium bright stars. And the story is that Sagittarius the Archer, who's way down here, oh, there he is, there's Sagittarius the Archer, shot an arrow at the eagle and missed. And there's the arrow Sagitta sort of going up above the eagle's beak. Vulpecula the fox, which is not really any, not really any shape, constellations there. There's not really a shape to the pattern of stars. But there is this is where the Dumbbell Nebula is. And actually I won't zoom in on it because we'll take a picture of it here. We'll get a live view of it in just a minute. Something else that's in Vulpecula that I think is interesting is the so-called coat hanger cluster. So these are star patterns. This is what you might call an asterism, where it's a little pattern of stars that looks like something. The Big Dipper is a good example. The Summer Triangle is actually an example of an asterism. The Pleiades, the Seven Sisters, is a little star cluster that looks like, some people call it the Little Dipper, the Little Dipper, the Teeny Tiny Dipper, the Baby Dipper, because it looks a little bit like a dipper. Here's a little cluster of stars called the Coat Hanger Cluster because it's kind of upside down right now, but there's where you hang your coat, and there's the hook right there. You can see some of the brighter stars with the naked eye, but you can really easily see it with binoculars. So it's a great, if you get some binoculars that you're interested in using for astronomy, look at the Summer Triangle, right? Let me show you where the Summer Triangle is. So there's the Summer Triangle. Find Albireo, which is this double star I mentioned, and then sort of between Albireo and Altair is the Coat Hanger Cluster. And then a little bit to the left are the stars in Sagitta the Arrow, like so. Now, one of my favorite constellations is over here, and this is Delphinus the Dolphin. It's just a lovely little, asterism. So there you can see what it looks like. If the sky is dark, it's easy to see with the naked eye. It's got this little quadrilateral shape up here at the front, and then a nice little tail off the back, and it's a little dolphin jumping out of the waves over in the plane of the Milky Way. So if you do get a clear night this week, definitely go outside, find Jupiter and Saturn, find the Summer Triangle. If you're lucky enough to live someplace where it's dark, look for Delphinus the Dolphin, look for the Coat Hanger Cluster, and look for Sagitta the Arrow right in there. Okay, now we're getting short on time and it's getting more cloudy, so let's go take a look at the Dumbbell Nebula and then maybe the M11 cluster, and then if there's still time, maybe M57, the Ring Nebula. Okay, so I'm going to switch back to my telescope control here. I'm still checking the chat, so if anyone has questions or requests, feel free to throw them out there. All right, so we're still looking at Saturn. So there's another live image of the moons of Saturn. And let me move the telescope. So I'll hide the camera live view for a second. I'm actually, when I switch to the Dumbbell Nebula, I'm going to have to change modes of the camera because I want to take a longer exposure using the camera more like a camera than a video camera. Instead of taking a bunch of frames, I'm going to take longer exposures. So let's first move the telescope. So the Dumbbell Nebula is up kind of right in here. I can just say find M27 is the Messier number. Okay, so I have a question. When using a Barlow lens with my telescope, should it be placed before or after the star diagonal? Oh, that's kind of a technical question. Usually the Barlow lens is right at the back of the telescope, and that's something that makes the focal length longer. It actually, as long as you have enough focus travel in the telescope, it shouldn't matter. Yeah, actually, I would put it behind the diagonal, because then you know that the focal plane is going to be, you know that the focuser travel can get the focal point behind the diagonal, and so that's where the Barlow lens is going to start diverging the light. So it should work either way, but I think putting it behind the diagonal would be better. Okay, let's move to M27. You'll see the telescope moving up there. Here, I'll switch to the camera so you can see that. There it goes, up, 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 towards the summer triangle. I'm not moving very much east-west, so the counterweights are still right here in my face. not in my face, but right next to me. Okay, and I actually am going to need to switch camera modes, so give me just a minute to do that. Okay. Okay, so let me connect to the camera again. And I haven't used the camera as often in this mode, so it may take me a minute to remember how to do things. Okay, good. Okay. Uh-oh, my program crashed. Let me try again. Connect to the camera, please. Aha, there we go. All right, that's fine. All right, let me show you what I'm seeing here. Okay. All right, so I'm using the camera in a slightly different mode where it's going to take longer exposures and add them together over time. And I can already see the nebula because I know what it's supposed to look like. But I can see, that the stars are roughly in focus, so that's good. This is a single-shot color camera, so it has filters built into the camera so that it can take color images, just like a commercial point-and-shoot camera or a cell phone camera or anything like that. Now, I'm going to switch to the stacking mode, and I'm taking 5-second exposures, and what's going to happen is that it's going to get, okay, so it's going to get better and better. Basically, it's going to get less noisy because it's combining several images in a row to get a better image. And I can show you the last image that it took and then the most recent one. I'm actually going to stop that and take a longer exposure. I'm going to do a 10-second exposure. Yes. Okay. So we have to wait 10 seconds to get the first image. I may need to go, it may be helpful if I go turn off the deck lights, just because that contributes to a little bit of local light pollution. Well, I won't do that because then you won't be able to see me anymore. Okay, so now I think we are, yeah, there's a single image and then there's a stacked image. So we're just going to wait a couple of minutes. Oh, the cooler is not on. Let me turn on the cooler. That will definitely help. Okay. Yeah, low gain. 2x2 binning. Okay. I think this is looking actually pretty good. And so let me do some sort of brightness and contrast adjustments here. The sky to be a little bit darker. We do have a lot of light pollution here, so you're seeing that in the background. All right, I think we're starting to see the nebula there. What is that bubble developing in front of those stacked shots? Yeah, we're starting to get the nebula here. And so as these are coming in, I can talk a little bit about what we're looking at. So this is the Dumbbell Nebula, which is a planetary nebula. So this is a star sort of at the end of its lifespan. A little bit more contrast, a little bit more saturation so you can see those colors a little bit better. When a low mass star like the Sun, basically this gas used to be part of a low mass star. When a low mass star reaches the end of its life as a star, the core has burned all its fuel, so converted hydrogen into helium and helium into carbon. The core can no longer support itself, so it collapses. Now for high mass stars, that happens in a second, and the collapse blows off the outer layers and makes a supernova. And then what's left is potentially a black hole, a super dense remnant of the core of the star. For a low mass star, the core kind of collapses more gently, the outer layers blow off more gently. You don't get a supernova, but you do get this pretty object called a planetary nebula. And I'm just trying to get the best brightness and contrast that'll make the sky look a little bit darker, but not completely lose the nebula. Hey, that's not too bad. And so the core of the star, you can actually see it right here. The core of the star is right there. So that's a stellar remnant called a white dwarf. And the nebula itself, it's taking a little while to kind of fill in against the light pollution that we have. And the haze, there's a little bit of haze up there that makes it a little bit harder to see the faint object. So this is, definitely. So the white dwarf is really obvious because it's quite blue. You know, these are background stars, and the white dwarf is very hot. It's very small. It's about the size of the Earth, in fact. So it's something about the mass of the sun, or maybe half the mass of the sun, squeezed down to about the diameter of the Earth, heated up to maybe 40 or 50 or 100,000 degrees. And so it's glowing blue-white. It's not super bright because it's so small, but you can definitely see it in this nebula. So I think that's okay. I think the light pollution and the haze is making it a little bit harder to see. I'm going to show you another example of a planetary nebula, and I'm going to save this image. Okay, so I'm going to stop the readout. Okay, and make the camera a little bit colder, like so, and save the image. Okay, and we're going to go look at the Ring Nebula, which is nearby. It's up in the constellation of Lyra, so it's actually also in the Summer Triangle. So we'll zoom back out here, and we'll clear this. Okay, it's still taking images. That's fine. I mean, I could stop it. And let's move to the Ring Nebula. This is it's over on the other side of the meridian, so the telescope's going to flip over. I guess that's okay. So it's on the other side of the sky right now. Doesn't look like it's behind the clouds. It looks like it's clear where it should be. So let's try this. Okay, so we're going to move the telescope. The telescope's actually going to move pretty far, and it's going to be over on the other side of the telescope mounting the pier. So the telescope will be closer to me rather than the counterweights. So the counterweight's here. I'll switch to the camera so you can see what's going on here. So the counterweight bar is going to swing down to the bottom and then back up, and the telescope is going to swing down and point more or less directly overhead. We'll take a peek at this object, and then we'll take a peek at a star cluster, and then I'm going to need to sign off for tonight. You can see that red cylinder at the back of the telescope. That's the video camera, the CMOS video camera. This is a camera that we bought for doing live remote observing for students earlier this year in the spring. And it's fairly popular with amateur astronomers. It's a reasonable camera to buy for amateur astrophotography. It has a few drawbacks, but it's not very expensive, and it does take true color images. It has the built-in filters, and it has that built-in cooler, which makes the images look better, less noisy. You know, the camera is just part, if you're trying to get into astrophotography, the camera is, you know, maybe you should spend 1/4 of your budget on the camera, and then 1/4 of your budget on the telescope, and then half your budget on the mount. Because if you don't have a good telescope mount that can hold the telescope steady and track the sky, all of your images are going to be wobbly, and they're not going to look good. Okay, let's see if we've got the Ring Nebula in focus here. So we'll start taking images. Hey, it's right there. This one is actually brighter than the other one. It's smaller. Are we stacking? Stack, stop. You start the stack. Let's start the stack. 10 seconds. Okay. I think that's good. Okay. There's this button here that will remove any images. If I see a satellite or a plane fly through or something that could ruin the image, there's a way to undo it, and then there's a way to start over. Okay. All right, so this is another planetary nebula. Oh, and you know what I have to do? I have to restart one more time. Clear. Okay, one more time. Okay, there we go. Lots of, this nebula is kind of closer to the plane of the Milky Way, and so you can see more of the background stars kind of around it. You can still see that white dwarf. Now, it's going to take a few minutes to combine enough images so that it looks better. But there's the bluish white dwarf right in the center of the nebula. That's the core of the low mass star that exploded. And then you can see this colorful reddish, bluish, greenish ring. It's like a smoke ring. When you look at it with your eye through an eyepiece, you can't see the color very clearly. Your eyes just aren't sensitive to color when you're looking at a faint object. And it looks like a smoke ring or a Cheerio in space. So you need a longer exposure in order to get those colors and those details. Hey, this is looking pretty good. I've got some camera artifacts in there, which I can remove. I can edit those out. There's ways to calibrate that out. You see some red dots and some blue dots. Those are problems with the those are calibration problems with the camera, which you can remove after you've taken the image. But yeah, I think that looks pretty good. Let's see. Oh, Hillary, your kids, one of your kid is 8 and loves space. That's great. This telescope that I have right here is a great sort of starter telescope for 8's a little young for a telescope, but not really. A mature 8-year-old could probably get a lot out of using binoculars and telescopes. I'm just sort of thinking my kid is 2, and I wouldn't trust him with a telescope. But it's a great thing to do with kids kind of 5 to 10 is to get a star chart and a pair of binoculars and go out and learn the constellations. And then I'd say starting around 8 to 12 is a good time to get a telescope and teach them how to find things in the sky with a telescope. Start with the moon. The moon's the easiest thing to find. And then start with the bright planets. And then look at some of the double stars that are out. It's a very rewarding hobby. Okay, well, I think that's enough on the Ring Nebula, and I will also save this image. And we'll take a look at a star cluster. I think we'll go take a look at either M13 or M11. Let's see, where's M11 in the sky right now? M11 is known as the wild duck cluster. M11 might be in the trees. No, I think it should be okay. It's a little bit above Jupiter, and Jupiter is not in the trees. Okay, let's move to M11. Here we go. So you will see the telescope move down further south, kind of closer to where Jupiter was. Actually, you know, the last thing that might be interesting is to take a quick peek at Jupiter and see if Io is still casting a shadow on Jupiter. Because the moon's orbits so quickly and Jupiter rotates so quickly, you can see changes within half an hour or so. Okay, so let's switch back to the telescope control and let's start taking some new images. Aha, there it is right there. This telescope mount is overkill for this telescope. It's super accurate and you find things right away. It makes it too easy. Okay, so this is an open star cluster, and we'll save, you know, we'll add together some images that you can see in the plane of the Milky Way. And I'm going to make it a little bit darker in the background. There we go. And I'm going to make those stars a little bit less bright. There we go. And you can see some nice colors in the stars. So you can see some of the stars look a little bit oranger or yellower, and some of the stars look a little bit greener or bluer. So the oranger stars are less hot, they're cooler, but you see they're still pretty bright, so that means they're really big. So those are probably the red giants. Whereas the bluish stars are pretty hot. Those are probably stars that are still so-called main sequence stars. They're probably still normal size, burning hydrogen into helium. Stars form in these clusters, so you can have a cloud of gas and dust in the Milky Way, and over a few tens or hundreds of millions of years, the gas collapses to form a group of stars. The stars blow away the nearby gas, making nebulae like the Rosette Nebula or the Eagle Nebula. This star cluster has long left the part of the Milky Way where it formed from a gas cloud. But still, there are a few thousand stars, well, maybe about 1,000 stars, all orbiting around each other in this kind of cluster. The sun would have formed in a star cluster like this. But of course, over time, we've drifted away from the stars that were born at the same time as the sun, our litter mates, so to speak. We've lost them as we've made about 20 or so orbits around the Milky Way in the history of the solar system. Okay, that's pretty cool. I'm going to save that image. And Jupiter's not in the clouds. No, it's not in the clouds yet. So let's take one last look at Jupiter, and then we'll stop for tonight. Oh, but I have to switch the mode of the camera back, so I'll do that. Okay, there goes the telescope moving down to Jupiter. I think it's actually gotten a little more clear. It was supposed to get more cloudy, but maybe it's gotten a little bit more clear. There were some big clouds, big puffy clouds coming through about 20 minutes ago, but most of those have gone away. There's still a few clouds. Okay, so let's switch camera modes here. All right, there's our old image of the cluster. We're going to go back to the video mode. Okay. And I'm going to have to turn the camera on here in this mode. All right, so there's Jupiter still. Hey, it looks like there's a new moon. Oh, okay. So something interesting has happened. The telescope now is on this side of the pier, so it's flipped 180 degrees compared to what it was before. So Jupiter is flipped 180 degrees from what it was before. Now there may be an easy way to flip it in my software here, but I haven't looked up how to do that yet. So just flip it upside down in your mind compared to what we saw earlier. Right. So there's Io right there, and there's Europa over there. And now Ganymede, it looks like, is still behind Jupiter, and Callisto is off to the right, kind of out of the field of view. So let's kind of zoom in a little bit here and get a sharper image. Hey, you can see that Jupiter's rotated quite a bit. The red spot was sort of more there, and you can see it's moved over there. And I don't see the shadow anymore. It looks like the shadow is gone. So Io has moved enough away from Jupiter that the shadow is no longer falling on Jupiter. That's neat. I'm going to do another little video here, and I'm going to compare the earlier image to the later image. If I can get a good... All right, there we go. Take 100 frames in the video. Okay, well, I think, it's not as much fun watching a video of Jupiter or Saturn or a star cluster over the internet as it is, getting your chance to put your eye at the eyepiece and see the photons from Jupiter go onto your retina and be detected by your brain. But given the isolation we have to endure at this time, this is the next best thing. So I really enjoy getting on and sharing all of this with you. So thanks for your attention. As soon as my image is done here, I'm going to sign off. Let me see if there are any other questions or comments in the chat. Okay, so let me turn this off. Okay, so thanks for participating in the live stream. The recording will go up on the Leitner Observatory YouTube channel, and so you can watch it again later on, or you can watch any of the previous live streams that I've done this past summer. Some of them at the very beginning, when I wasn't allowed to come to the observatory, I did in my backyard, which was fun. Fun in some ways, not fun in other ways. So it's nice to be up here at the observatory teaching and doing this live stream and so forth. So I'll try to do this again next Tuesday. If it's clear, I'll set up some telescopes, so we'll look at some different objects. If you want to keep up with what's happening at the Leitner Observatory, we have a website which is Leitner Observatory, L-E-I-T-N-E-R. Right, it's in the title of the video, observatory.yale.edu. And if anyone has any questions about astronomy, about Leitner, about Yale astronomy, anything that I've talked about, I'm happy to answer emails if you have an email, or you can post comments in the video here on YouTube. So my email is michael.faison, F-A-I-S-O-N, @yale.edu. All right, well, have a good night, everyone. Clear skies. Hope the week goes really well for all of you, and I'll see you next time.